All right, today we're going to learn our third way to solve a simultaneous system of equations, and this is by elimination. It's not what it says in your book. They give you a really long phrase by adding and subtracting, I think, but there's more to it than adding and subtracting. If we looked in the algebra textbook, it has a much better definition. It's elimination. Now, what's the root word of elimination? Eliminate. And that's what we want to do today. We want to not do all that. Whew. Pen went crazy. We want to eliminate one of the variables. That's going to be our goal today. Eliminate one of the variables. What were the first two methods we had? First one was hard. Yes, it was a lot of work. Graphing, yes. Thank you for being so descriptive, Steve. Graphing. Second method was substitution. Still better than graphing, but the problem with substitution was it's a lot of steps, isn't it? For those of you who did your homework, you'd realize that. Today we want to eliminate one of the variables, Isn't that nice? Typo. We want to eliminate one of the variables today. And we are going to do that by having one of them drop out. Now, how are we going to do that? Well, we want to add down. We want them to add to 0. Remember when we were doing two-step equations and we would do the opposite operation with the same number so that they would add to 0? Does that sound familiar? We're going to do the same thing today, except instead of those being numbers, we're going to look at the coefficients in front of the variable. And the nice thing is you get to pick which variable you want to get rid of. Now, some of them will be set up so it's more easily done. Like if we look at this first problem, what I want to do is add down, and I'm going to add them in columns. Now, this one is set up nicely. What do you suppose might be a prerequisite in order to do the elimination method? Yes, I'm going to have one positive and one negative, but even before that, how will the equation have to be set up? In what form? Louder, Luke. Standard form, right on the money. I have to have all of these in standard form first. If it's not in standard form, you have to put it there. Most of them will be in standard form already. But like I said, on your test and your quiz, I don't care which method you use. Some of those are going to be set up to graph, which means it'd be in slope-intercept form, which means you'd have to do what first? Move it back to standard in order to use this method. But that's one extra step. This is still so much faster that it'd be faster than graphing. All right, so what we want to look now, we want to look to see, do we have two, with one of the variables, do we have two of them that have the same number coefficient but opposite signs? Do we have that there? Yeah, look at the x variable. This top one's a positive 2, bottom one's a negative 2, which means when I add down, what's going to happen to them? It's going to be 0. So that's what I want to do here. I want to add down. I'm going to add every column. 2 plus a negative 2 is 0x, which is just 0, which means it's nothing. I have 0 plus whatever the y is going to be, so that just cancels out, right? So 3y plus 1y is 4y. Don't need that 0 there. Equals 6 plus 2 is 8. Now, the opposite of multiplying by 4 is to divide by 4. Y equals 2. This, we would have gotten this with substitution, but it would have taken us about 4 extra steps. So who likes this way better? Yeah, isn't this great compared to all that other work? Now, here's the disadvantage of the elimination method. I got to plug y back in, plug the value back in for y, and this is not solve for x. But big deal, you'll still be able to do it. It'll be like working on a two-step equation, stuff we've been doing since October. So that's what I'm going to do next. I'm going to plug in this value for y. You can pick either one of these equations. Which equation looks easier to solve? Which one of these two looks easier to solve to you? The top or the bottom? Really? I'm thinking bottom, because there's no coefficient here in front of y. Y is by itself. I would plug into the y. You know what though? You could plug it in the top one and it wouldn't make any difference. You're still, as long as you do the math right, you still get the same answer. Alright, so I'm getting a coordinate here. I know the y is 2. I plug in 2 right in here for y, and I get negative 2x plus my y is 2 equals 2. Does anybody see what the answer has to be already? Well, what are you going to add to 2 to get 2? 0, yeah. I'll go ahead and finish the computation. I subtract 2 from both sides. I get negative 2x equals 0. Divide by negative 2. 0 divided by anything is 0. So my ordered pair is 0, 2. So this is much faster, isn't it? It is. Yes, you would have to multiply the 3 by ask me later. I'm live right now. And this is going to be, so I'll answer that for you later. All right, this one. Well, if I look at these, the y's have the same coefficient, right? But the signs are the same. So is there a way to change, because if I could change the sign on this bottom one, I'd be golden, wouldn't I? You sure can, Steve. Boy, you're like on fire today. You can. You had McDonald's. Oh, there we go. Free promo for McDonald's. Is their coffee any good? The new stuff? Yeah. Yes. McDonald's, the new McDonald's coffee. Is it good? Oh, it's the same stuff. It used to taste like sludge, so it still does. I like Dunkin' Donuts coffee. Alright, what I'm going to do is I'm going to change the sign of everything on that bottom. That happens, or that is the result of really multiplying everything by negative 1. So I'm going to distribute this negative sign to everything. So on the top I get, stays the same. And on the bottom I end up with negative x minus 4y equals 10. Well, the y's will cancel. 3x minus 1x is 2x equals 24. Divide by 2. X equals 12. Alright, so my x coordinate is a 12. Now I'm going to plug back in, and I'm going to plug into this bottom one because x has no coefficient. So I get, so x is going to go right into that one, right there. Wow, there we go. And we get 12 plus 4y equals 10. What do I have to do first? How? Subtract 12, yes. 12's over here. It's kind of backwards what we're used to saying. Subtract 12, because that's positive 12 right here. I get 4y equals negative 2. Divide by 4. Now, do I actually have to divide? No, that's a fraction, right? So I'm going to reduce it. You could divide, you get negative 0.5, which would be fine. I don't care if you put it as a decimal or a fraction. Negative 1/2, which is the same as negative 0.5. Either way is fine. All right, here we have another system. What's the problem with this one? See, this whole thing is a problem-solving approach. Yeah, the coefficients aren't the same in either of them, right? But the last time I multiplied it by negative 1, right? In this last problem, right here, I multiplied this whole thing by negative 1. So do you suppose that's like a clue as to what I could do here? Yeah, I can multiply any of these by anything. As long as I multiply the entire equation by the same thing, I have not changed its value. I've changed the numbers you're looking at, but the overall value of the equation, if I graphed it on, put it on a graph, it'd still be the same line. Doesn't change. So I'm going to multiply this entire bottom by what? I have two choices. Negative 2 or negative 3. You get to pick which variable you want to get rid of. How about y? Or x. I guess we get rid of x. That's fine. Negative 2. That way we're dealing with smaller numbers. We'll multiply everything by negative 2. So we get 2x plus 3y equals 8. And on the bottom we get negative 2x minus 2y equals negative 3. Ooh, yeah, I'm glad we picked that one. Those cancel, and I get, look at this, 3 minus 2 is just 1y, right? So one step, and it's so... Oh, yeah, it would be positive 6. Oops. Yeah, thanks. Remind me to give your points. So y equals 14. Be careful with that. I just made the most common mistake made by students. They'll forget to multiply everything by the negative 2. So even that gets the negative 2. All right, so y equals 14. That's half of my answer, my ordered pair. Let me plug back in for 14 and for y right there. So x plus 14 equals negative 3. Subtract 14 from both sides, one step. X equals negative 17. Question? You sure? Okay. So now we can see that we can multiply the equation by anything, right? To manipulate. That's what we're doing. We're manipulating the equation to make it just what we want. Sometimes, though, we're going to have to do it to both. Because there's no way to change this bottom one to get 7 here or 2 here, is there? I mean, I can multiply by fractions, but that's going to make it very ugly. So there's no rule that says I cannot multiply both of them. Which means, what do I want to do? I either want to change these to the same number or change these. Now, which one's going to be easier, the x or the y? The y, right? Why will the y be easier? The numbers are closer together and they're smaller. That's right. So I'm going to multiply the top one by 3, and this is just personal habit. Now I've got to change their signs also, right? Because they're both positive. So what would I multiply the bottom by? Negative 2. And I always like to multiply if I have to change the signs and multiply both of them, I always like to do the bottom one, make it negative. That's just my habit. You don't have to. I could have multiplied the top one by negative 3. But I always like to, when I add, have my negative on the bottom. I don't know why, I just do. So I'm going to distribute 3 to everything on the top. 21x plus 6y equals 15. And then negative 4x minus 6y equals negative 32. Add down. 21 plus negative 4 is 17x. Those cancel right there. They're gone. Equals negative 17. Divide by 17. X equals negative 1. All right. I got negative 1 for x. Now I can plug back into either one of these. It doesn't really matter. They're both going to be equally as difficult. So I'll probably pick this one because it's got smaller coefficients. 2 times negative 1 plus 3y equals 16. That's negative 2 plus 3y equals 16. Add 2 to both sides. That's the opposite of a negative 2. 3y equals 18. Divide by 3. Y equals 6. There's my other number. Negative 1, 6. Any questions so far? So, I can multiply one equation. I can multiply both of them. Just your key is this. They have to be the same coefficient with the opposite signs. So sometimes you have to multiply by one positive and one negative. No. This is instead of graphing. It's more accurate than graphing. Is that our ordered pair? What's the whole point of all this that we've been doing, other than me to annoy you? To get what? At the end where it intersects, that one ordered pair where the two lines intersect. And if we can do it without graphing, great. Kate has nickels and dimes in her pockets. In her pocket. There are 11 coins. The coin's value is 95 cents. How many of each kind does Kate have? Well, this is also a system, and we're going to use this. All right, the first one. We have to come up with an equation here, a system. So we're going to let n equal nickels, isn't that original? And d equal dimes. I'd do capital D then. So what do I know? Yes, and if I add n plus d, how many coins are there? 11. So I know the number of nickels plus the number of dimes has to equal 11. What else do I know? Well, I know what their values are, right? 0.05 times the number of nickels, because nickels are worth 5 cents, plus 0.10 times the number of dimes has to equal what total? 95 cents. You figured it out? Okay, good. It's probably easier just to figure it out in your head. Yeah, 8 times 3 nickels, you're right. But there is a mathematical algorithm to this. Wow, is that ugly. The first thing I'm going to do is multiply all of this by 10, by 100. Why am I going to do that? So I can have whole numbers and to get rid of the decimals. That's ugly. N plus D equals 11. And then 5n plus 10d equals 95. All right, now I can set them up to move around. What do you want to multiply? What letter do you want to get rid of, N or D? D? So what are we going to do to get rid of D? We'd have to change this top one, right? What do we have to multiply it by? That's a 10, so to get rid of D, we'd have to multiply by negative 10, because that's positive 1D. Or we could have multiplied by negative 5n. Negative 5 to get rid of n. Doesn't matter. So I get negative 10n minus 10d equals negative 110. 5n plus 10d equals 95. Would have just been easier to do this in our head, wouldn't it? Add down, huh? Yeah, you used a closed system. That's what you used. And that would have been easier. Negative 5n, those cancel, equals negative 15. Divide by negative 5, n equals 3. So you have 3 nickels, you know, because it's a closed system, you have 8 dimes. So 3 nickels. It's quite insightful, sir. This will be due on Monday.